Hello, my name is Luke Cronin, and today I'll be going over part 4 of my Bluetooth garage door opener device, which is the testing. So to begin, the things that have changed since the last video, the circuit is now soldered onto a proto shield, which is placed directly onto the Arduino. The circuit itself is placed within the enclosure, so the Arduino with the shield attached and the Bluetooth module. The device power supply is now being shown in the video, which is a 10-watt USB block. So typically it is used for a phone charger, but in this case we'll be using it to power our garage door opener. And from that 10-watt block, we will be using a USB-A to USB-B cable. Also, the user interface for the app is changed, which I will go over later in this video. To begin, I will do a rundown of the code once again. So nothing has changed with this code. So we begin with defining the pins. We then define the inputs and outputs. And then we jump into the loop where we look for certain values received through the serial communication on the Arduino. And this code was explained in the last video, and nothing has changed here.
So now I'm going to give a very quick rundown of the circuit while it is now not on a breadboard, it is on the proto shield. So the circuit is essentially the exact same. We have the relay connected to ground, VCC, and IN1, and IN1 is connected to port 13 of the Arduino. Then we have the Bluetooth module, which is connected to the TX, RX, 5V, and ground of the Arduino. And like before, we have the button, which is right here, which is connected to ground via a pull-down resistor, connected to 5V, and then connected to pin 2, which can be seen through that solder connection right there. And then we have the Bluetooth indicator LED, which is right here. And then that is connected to pin 8 via this resistor right here, and then also connected to ground. So some connections were soldered, the more permanent ones such as the resistors and the voltage divider for the receive pin of the Bluetooth module, and the resistor of the button, and then the resistor of the LED. Along with some of these jumper cables were also soldered so that there would be a better connection. The connections that weren't soldered were the relay module and the Bluetooth module, simply because these aren't my devices, so I will have to give them back, so I wanted to use something less permanent. But nonetheless, these cables do offer a good connection, and even if the device is kind of jostled around or moved around, these connections still shouldn't come loose. Also, here's the proto shield actually disconnected from the Arduino. You can see some of the connections there on the bottom. And yeah, so this just directly connects to the Arduino. And then that is it. Then you can just plug it in and the device will work. Here is the enclosure that will be used for this project. So as you can see on the inside, we have some holes to mount the Arduino. We have 2 holes for both the USB or barrel jack connector, depending on how the device will be powered. And then on the back we have 2 holes which will connect directly to the garage door, which will be shown later in this video. On the lid we have a hole right here which is for the Bluetooth indicator LED, and a hole here which is for the button, and then these holes are just for aesthetic. Also, this small piece will be used as a button. So because the push button is very small, it may be hard for some users to kind of get their finger in this small opening to actually open or close the garage door. So this small piece was printed to enlarge the size of the button so that it's more user friendly. Here is the device with the lid off actually in the enclosure. We have the relay module and the Arduino mounted to the enclosure with the shield on. And as you can see, the two cutouts allow for the USB cable to be plugged into the Arduino. So just to show again before I put the lid on, this is how the device actually connects to the garage door. This was shown in the previous video, but I just wanted to show again. So the garage door connects directly to the relay in the normally open position, and then through this wire which goes up through the ceiling and then connects directly to the garage door motor. So here's the device in the enclosure with the lid on, fully connected to the garage door. And now I will give a demonstration of how the device works. So we have the open and close button right here, which is clearly labeled, and then the Bluetooth indicator button. Again, we have the two wires that connect directly to the garage door, which connect to the relay inside the enclosure. And powering the device, I'm using a USB-B to USB-A cable, which is connected directly to a wall outlet, which is using a 10-watt just power supply, a regular phone charger, which was outlined in part 1 and part 2 of my documentation. So you just plug your device directly into the power and into your garage door opener. And the device is already plugged in. So now I will move over to my smartphone. So go into your Bluetooth options first, and here you will see HC-06. You will be prompted to enter a passcode, which by default again is 1234. So you enter this passcode, and you are then paired, and then you will enter the garage door opener app. So the GUI is a bit different, which I'll go over later in this video. But you want to first connect device and then choose your garage door opener. You can have more than one, which is why you had the option to choose, but I only have one in this case, so I'll choose this one here. Then once it is successfully connected, we will see the Bluetooth LED turn on. Yep, so now we know we are connected. So we also see it in the app via the connected, and now the disconnect button has turned red. And now we can press open or close to open or close the garage door, which I will now show. So now by pressing open or close on the app, we'll open or close the garage door. And you can also hear the audible noise of the relay clicking when pressing this. It may be hard to hear, but you can hear the relay actually clicking. And again, if you don't have a mobile device on you and you still want to use the garage door, you can simply just press this button and the garage door will open, as you can hear in the back. And then pressing it again will do stop it, and then pressing again will close. And lastly, if you did for some reason want to disconnect from the garage door opener device, you simply just press disconnect here. You will see the app GUI change, and you will see the Bluetooth indicator LED turn off. Also, to quickly note, the device is mounted to the wall just through a simple adhesive material. So now I'd like to go over the updated user interface and all the features that have been changed since the last video. So once you connect to the device in the Bluetooth settings, which was shown in the demonstration, you just go to the app here which is still shown by the MUN Engineering logo, and it is called Garage Door. So when you first open the app and you do not have the device connected, you will see this. So you will see a how-to screen, which goes through some easy to follow instructions on how to actually connect your mobile device to the garage door opener. And we have a connect device button, an open close button, and a disconnect button. So the open and close button has been moved further away from the disconnect button so that you don't accidentally press the disconnect button. And unlike last time, you cannot actually press the disconnect button now until there is a device connected. And if you try to, you will get an error indicating that a Bluetooth device is not connected. So to connect your device, you first just press connect device. You'll see a list of the receivers you have connected. In my case, I only have one. So I will connect. And as you can see, the user interface now changes once there is a successful connection. And you can see that there is a successful connection by the Bluetooth indicator LED actually turning on the device. So you can see that the connect device button has changed to connected. The open and close button is still the same. We still have the how-to screen, and we have the disconnect button, which has now turned red, indicating that the device actually can be disconnected now. And if you do press disconnect, then the device will disconnect. You will see the Bluetooth LED turn off, and you will see the user interface go back to when in the state that it goes to when the device is not connected. So you'll see the disconnect button doesn't work, and the connect device button turns back to blue and shows that you can connect the device. So just real quick, I'll do another quick demonstration. So like before, I'm just using an LED to indicate the short pulse. So the LED is always on, and then when I press open close, it turns off, which simulates that short pulse that opens or closes the garage door itself, shown previously in this video.
Now I will go over how the changes in the app were actually made and what actually was changed in the blocks for the creation of the app. So here we can see the user interface, which was shown in the previous clip. So I will move on to the blocks, which show what exactly is happening. So again, I'm using MIT App Inventor to create this app. So first we have the list picker, and this is the exact same. So when you press that, it brings up the Bluetooth devices that are connected to your device. We have when selecting the list picker, so you connect to whatever your selection is. Then we change that button to say connected. We change the background color to green, and then we actually set the disconnect button to red so that it now indicates to the user that it can be pressed. And then we send a 3 to the Bluetooth module, which then sends a 3 to the Arduino, which triggers that blue Bluetooth indicator LED on the device itself. We then move to button 1, which is the open and close button. So nothing has changed here. When we press that, we send a 1 to the Bluetooth module, then to the Arduino. And when the Arduino sees a 1, it triggers the relay to close, sending that short pulse, triggering the garage door to open or close depending on its previous state. Lastly, we have button 2. So when we press button 2, we send a 4, which turns off the Bluetooth LED. Then we call the Bluetooth client to disconnect from the Bluetooth module. And then we change the button, the connect button back to connect device. We set its background color back to blue, and we set the disconnect button to gray, indicating to the user that they cannot press the disconnect button because obviously nothing is connected. And if they do connect it if they do try to press it as shown, then the app will give them an error indicating that nothing is connected. And then once again, just heading back to the designer, we do have a image here that guides the user on how to exactly hook up their garage door opener device.
So to conclude, I just wanted to give a quick rundown on how this project will be completed. So there are no calibration steps needed for this device, but one thing that will definitely need to be done is improving the cable management. So right now, as you can see with the lid off, there are quite a lot of cables going everywhere. They're very long and some of them are even tangled. So this obviously isn't good, as the wires can fray and the connections can loosen and even maybe cause short circuits. So I obviously want to reduce those risks. So this will be done by either shortening the cables and improving the connections and wire management within by using things such as zip ties or elastic bands to kind of keep the cables in one place. Or an actual Arduino shield will be designed. So a PCB will be designed which fits exactly on the Arduino like here, but all the unnecessary pads, buttons, pins will be removed, and the circuit itself will be implemented on that PCB. In the next clip, I'll show how this relay module can also be reduced in size so that the enclosure can also be reduced in size, which will make the device much more user-friendly, reduce the amount of material needed to actually produce this device, and overall simplify the entire device itself. So just a very quick explanation on how this relay module will be reduced to a smaller size on the actual PCB. So this obviously does work, but it is a bit bulky and it does increase the size of the package quite a bit. So I just made this quick circuit, which is essentially the exact same as this, except since we're only using one relay, I have only one relay in this circuit, and these other components I will explain right here. So because the Arduino don't supply enough current to actually activate the relay, we have to use an NPN transistor, which is right there. Then we use a diode for some protection for the transistor. And then we just have the relay itself, which is functioning the exact same way this does, except just a reduced size.